Isomerism in alkene. Isomerism in alkene. Isomerism in alkene. Isomerism in alkene. Before starting our today lesson, hello everyone, good morning. I wanted to appreciate as you are subscribed my channel. Stand in front of me, behind me, all of you who lives near and far, sister and brother. Please follow our channel, subscribe our channel. So our today's lesson topic is isomerism in alkene. Alkene have three isomerism. Alkene have three isomerism: chain isomerism, possession isomerism, and the geometrical isomerism. Let us see one by one. Alkene containing carbon 2 and 3 have no isomerism. It means that it have only one possible structure. It represents only one possible structure. A compound which have isomerisms, it must be have more than two structures. So, the alkene, those have only one possible structure have no isomerism. So, propene and ethene have no isomerism because it have only one possible structure. So, alkene containing a carbon 4 and above have isomerism or exhibiting isomerism. So, butene have isomerism, pentene have isomerism, hexene have isomerism, heptene have isomerism, octene have isomerism, nonene have isomerism, decene have isomerism. So, if we see the first isomerism is chain isomerism, alkene have three types of isomerism. Alkenes have three types of isomerism. Alkenes have three types of isomerism. The first isomerism is chain isomerism. Chain isomerism. The second one is possession isomerism. Possession isomerism. The third one is geometrical isomerism. Geometrical isomerism. If we see definition of those isomerism by one, chain isomerism is isomerism due to the different arrangement of carbon atoms in the longest continuous chain. Chain isomerism is a type of structural isomerism due to the different arrangement of carbon atoms in the longest continuous chain. Let us see one by one. The first one is chain isomerism. Chain isomerism is isomerism due to the difference in carbon arrangement in the longest continuous chain. For example, butene. Let us take two butene, CH3, CH, double bond, CH3. This is representing the butene. This butene is called 2-butene. 2-butene. If we see the carbon arrangement in the 2-butene, let us see another example. This is 2-butene, CH3, CH, 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 CH3, CH3, CH3. This is the one, this is H. If we see this example, this is 2-butene. It is a normal butene. This is one methyl, one methyl, one methyl, one methyl, one propene. One methyl, one propene. This is an example of chain isomerism because here there is a 4 carbon arrangement. Carbon 1, carbon 2, carbon 3, carbon 4. If we come here, here is a 3 carbon arrangement. A 3 carbon arrangement. 1, 2, 3. Due to the different carbon arrangement in the longest continuous chain. Due to the different carbon arrangement in the longest continuous chain, we call it the chain isomerism. The chain isomerism. Because the carbon arrangement is differentiated. Due to the different carbon arrangement, it is called chain isomerism. What we call it? Chain isomerism. The other example is the possession isomerism. Possession isomerism. Possession isomerism. The difference between possession isomerism and the chain isomerism is due to the difference carbon arrangement in the longest continuous chain. But in the possession isomerism, due to the difference possession of the double bond in the carbon atom. Let us see the difference, how we can differentiate possession isomerism from chain isomerism. Possession isomerism. Possession isomerism. Possession isomerism. Possession isomerism is isomerism due to the difference possession of the double bond. Due to the difference possession of the double bond. Due to the difference possession of the double bond. And this means the definition of isomerism due to the difference due to the difference possession of double bond in the carbon atom, carbon chain, in the carbon chain. Let us see the possession isomerism of the hexene. Possession isomerism of hexene. Example: CH2 double bond, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. This is one hexene. This is one hexene. This is one hexene. The other one CH3, CH double bond, CH, CH2, CH2, CH3. 1, 2, 3, 4, 5, 6. This is 2 hexene. This is 2 hexene. And also the other one is CH3, CH2, CH double bond, CH, CH2, CH3. CH3. 1, 2, 3, 4, 5, 6. This is 3 hexene. If we see those hexene, the first hexene is half a double bond at the carbon number 1. The first hexene is half a double bond at carbon number 1. The second one is half a 2 double bond at carbon number 2. So that we call it 2 hexene due to the difference of possession of the double bond. The third one is 3 hexene. At carbon number 3, there is a double bond. Due to double bond is at carbon number 3, we call it 3 hexene. Due to the difference of the position of the double bond, carbon number 1, carbon number 2, carbon number 3, we say 1 hexene, 2 hexene, 3 hexene. 2 hexene, 3 hexene. So you can differentiate just like that. Position isomerism is due to the difference of position of the double bond in the carbon arrangement. The chain isomerism is the arrangement of carbon atom is different. The arrangement of due to the difference of carbon arrangement in the longest continuous chain, we call it the chain isomerism. If there is a position of double bond is different in the carbon atom or in the carbon chain, we call it the position isomerism. Our today's lesson topic is stop here. We continue in the next topic, alkane preparation. So until we have seen it, goodbye. Don't forget to subscribe, share, like our channel on YouTube. Our channel name is Online Science On. On our Online Science On channel, subscribe, share, follow our channel. Goodbye.